Dr. P.S. Goel, sir, former retired director, ISRO Indian Space Research Organization, Bengaluru. He has come down from Bengaluru to Chhatrapati Sambhajinagar, and he is here since the first day, and he will be there until tomorrow. We are starting the special scientific session. Now, the panelists are Dr. Gayatri Phade from Sandeep Foundation, Nashik. Welcome you, ma'am. Dr. Kranti Jakade, Assistant Professor, JNEC, Aurangabad, Chhatrapati Sambhajinagar. I welcome Dr. P.S. Goel sir on the stage. Padma Shri awardee of 2003. After retiring from the ISRO, he was requested to serve for the central government, and after his recommendations, the Ministry of Earth Sciences was created, and he was the first secretary of the Ministry of Earth Sciences. I now request the volunteer of Gyanyajnah Foundation, Mr. Atul Chapalgaonkar, to please welcome by handing over the flowers bouquet to Dr. P.S. Goel on behalf of us. Thank you. Now the panelists and the guest speaker, please take your seat. And the conversation may start. The initial speech by Dr. P.S. Goel, sir.
Namaskar, Jai Hind. First, I would like to congratulate the foundation, Ajay ji, and all the team for organizing this very unique festival for the first time in the country, which brings people from very different disciplines together. It's a kind of a bouquet of different kind of flowers. So, congratulations to you. It's a wonderful journey in the last 2 days, the way I have seen. And it's something very unique. I would like to address today mostly the students from the point of view of what exactly science is doing and how it affects the country, it affects the world. What I could do, and perhaps why I could do. Actually, I come from a very small village of Uttar Pradesh. We had no electricity, no roads. I saw a bus for the first time when I was 8 and took a walk to go to school in my 600, almost 10 kilometers. I didn't start with any ambition. The life unfolded chapter by chapter. And this I want to communicate to our youngsters, that this is something very important. Because when you get into your exercise of looking for a career, it just starts always with the next step. And that next step, it either sometimes happens by chance or sometimes happens by your effort. But your effort is important. For me, it was just a chance that I happened to go to Jodhpur because my brother got employed and he asked me to come along. One very simple thing happened when I was in 9th standard. In the year 1960, the freedom struggle was still quite alive. As young students, young boys, and we used to go out very often with flags shouting Vande Mataram and all that, which is not that often today. I happened to read a lot about the freedom fighting when I was in 9th and 10th standard. And I remember for a few months when I read about how the Bhagat Singh, Chandrasekhar Azad, Ram Prasad Bismil, or Ashfaqullah Khan, and all names which today earlier narrated by Mr. Shanti. There was a thought that why I was not born at that time, 20 years earlier, to die for the nation. But then one incident, a small incident, I read a story, someone told me, and then suddenly there was a realization that it's much easier to die for a nation, but much more difficult to live for a nation. And that's something, and many times later in my life, has come to take a decision. It made my decision making very easy. That you have to work hard, a tough life. Exactly like Mr. Shanti has said, it gives you a kind of a character by itself. My student life was very simple, in the sense that passing examination was probably effortless and went to engineering and all that, so that was a very simple thing. But then there are a few things which I remember, which I thought I'll mention to you. In my engineering college, we had a principal, Professor Garde. He was a very strict disciplinarian. He will stand in the front of his office in the morning exactly at 9 o'clock and actually monitor not only students but also teachers. It was a kind of a terror. But then in one of the first speech which I heard from him, he started like me. And he said, I'm an engineer, I know how to work, but I don't know how to talk. That sentence remained in my mind for a long time, that the profession of engineer is really to work. But then, when I went to ISRO, the first introduction which I had was from a quotation from a Sarabhai. And in fact, if you normally hear a ISRO person talking about any topic, he will start with this quotation. And the quotation is a long one, but the gist is that if you want to compete with the community of nation in the world, then you have to be second to none in the use of advanced technology for men and society. Man is a plural word there, man includes women. And that is a guideline which actually characterizes ISRO completely. And I'm sure the day that guideline is forgotten by our successors, the ISRO will be nowhere. So this is a very deep message in that guideline. And that guideline has actually shaped our complete ISRO program right from day one. In 1967, we started a program called SLV-3 and RS-1. It was a 40 kg satellite and a launch vehicle, SLV-3. I joined in 1970, and I was asked to work on control system of satellites, and particularly start with my career with RS-1. I was supposed to design a control system. And frankly speaking, in my engineering as well as masters at Indian Institute of Science, I had not heard anything about control systems of satellites. So I had to start with the basics, that means start reading the books, and got into the job. Why I mentioned to you is that many times people will tell that we are not training our scientists or our engineers for the job. That is a wrong statement. In fact, the training of students, your training as a science or engineering, is not really to prepare for a specific job, but the training is to give you fundamentals of science and engineering. And once you have those fundamentals, then the rest of the things comes application. And that application depends on aptitude. Some time back, Infosys, and you must have heard the name of the chairman, first chairman of Infosys. All of you know? Narayana Murthy. And he made a statement that I recruit people based on their aptitude to learn and do different things. For number one, he said, I cater to my customers. My customers will be different. Sometime it is a government body like electricity board. Next time will be an office in the, let's say, in the secretariat or somewhere else. So my engineers should be able to adapt to a different kind of a requirement. So what it means? It does mean that you are not trained for that, but you have to adopt for that. So the most important thing for an engineer or scientist is, it's important to read basics and learn, but more important thing is to have an aptitude to learn more and aptitude to different conditions. And the way the technology, particularly when we talk of the development of a country, comes, the needs are changing on a continuous basis. When I started my career, or I was a student, I was in Trivandrum, and it used to take minimum a day to make a call to Delhi. You book a call now, it's likely to come maybe next 8 hours or 10 hours. You may succeed or not succeed, you may get next day also. And today, the way revolution has taken place, who has done it? All engineers. You take any field of life. We talk of GPS, geopositioning system. It's a constellation of satellites which gives your location wherever you are in the globe with an accuracy, instantaneous accuracy of 3 meters. And if you stay for some more time, in fact, the scientists in geophysics are able to measure the motion of Earth, the so-called drifts and all that, to the accuracy of motion millimeter in 1 year from GPS. But of course, you have to do a lot of integration and all that. But these all technology developments have taken place. The same question applies to you. When you look at the technology developments, actually they have they're going exponentially. When you say what change took place in 1,000 years earlier, that 1,000 years change is less than what change took place in next 100 years. And what change took place in next 100 years is actually less than 10 years next. So the changes in the technology are growing exponentially. What does it mean? That means your ability to adopt for this change, learn new things, has to be comparable to that change. Because the word is race. It's not that if India does not do, world will stop. No. World is moving. Now, question is whether we are want to lag, we want to go with it, or we want to lead. It is a very different meaning. When you want to lead, the enormous effort you have to put. And when you want to go with it, there's also huge effort, but may not be through that level. If for a job, if I need to lead, I may put 10,000 engineers. If I want to continue, maybe 1,000 you will do. But otherwise, we are lagging. India per se has a very peculiar history. I'm just deviating a little bit, but I thought it's important for you to know. When you go for something like 5,000 years back, 3,000 years back, you will find the Indian technology much far ahead of the rest of the world. Whether you go for Mohenjo-daro or you go for, in your background, Ajanta, Ellora. Whatever has happened in Ellora is almost 500 years before Christ or 600 years before Christ. Something even probably earlier. How could someone carve such a huge hill or complete out of stone, 3-story? But we did that. Our people did that. You go to 5th century. I don't know how many people have realized that India was the most rich country in the world. We had almost 60% of GDP in the 5th, 6th century. Now we are much less than our average population of 16%, but at that time we were 60%. Things have changed. I'm not getting the history for various reasons, but our science and technology level went down. You analyze the way our defense capability have done, and you will find that over 3,000 years, we have lagged in technology for defense. Maybe reasons because of our religious faith, Vasudhaiva Kutumbakam, we thought no one will attack us, we don't have to prepare, all that can happen. But reality is that when Babar came, in fact even before that, when Ghaznavi and all that came, they had much better horses, we didn't have. When Babar came, he had cannon, we didn't have. Babar brought cannon to this country. When Britishers came, they came with a gun, very light and all that compared to cannon. We had cannon. We cannot fight a war with cannon when someone else has got a gun with him hand. And when, in our lifetime, when we were fighting with Chinese in 1963, they had automatic guns and our fellows had manually one at a time. We are very poorly equipped technologically to fight war with Chinese in 1963. 65 war with Pakistan, we won. But Pakistan had better planes, better ammunition. We won because they didn't know how to use it. They didn't know how to use these planes. It's a fact. It's an established fact. So even though technologically we were inferior to them, but we won because of they didn't know how to use those things. So similarly, you go further and you'll find that we have been lagging all along in our technology. I'll come to space, but before that I'll just tell you, because I'm on this topic of security. All of you remember 2611? At least the younger ones may not remember, but you are people who are born, let us say, because this is 2008, 2611. And one incident I just want to remind you. If you remember TV pictures, you will remember that in one of the houses, one of our commando warrior, Sandeep warrior, he was coming down using a rope into a window to shoot down the terrorists. He knew that in that room there are terrorists. This was being live telecast. The handlers of these commandos in Karachi, they saw this over satellite phone. They told that they are coming, and they shot down. Sandeep died. Actually, he was a son of one of my colleagues in ISRO. And you really see that they use the technology, our technology, but we didn't use any technology to our commando. We had same old guns. So there are a lot of historical things which tells us that we had been lacking in technology, particularly for fighting war. But coming to space, we had a visionary. Sarabhai gave a vision, Professor Dhawan gave the system what ISRO is. Absolutely committed to the words of Sarabhai. I started my career as a control system engineer to learn. As I said, I didn't know anything, but started working on Aurangabad, then Bhaskara, then Apple spacecraft, 3-axis control system. They are words, they won't mean anything to you because I don't want to get into details of the technology. But the idea is that how do we do communication, how do we do remote sensing, how do we give a data for agriculture, how do we give services to our farmers, how do we tell where we can make a pond, where we can make a check dam. We even worked on where do we drill wells in Rajasthan so that we can get water. We went to the satellite support for administration. Chandrababu Naidu was the first chief minister in Andhra that time to utilize much more space for digitizing systems. And everywhere, the communication satellite and remote sensing satellite, they became a backbone of every department and every services. And then, of course, navigation came, so we integrated navigation also into that. So our aim was that the life of everyone, every citizen, should get influence for the better. And if we are able to do that, then our effort is successful. And in that process, we did a lot more things for civil things, as I said, I'm not getting into the details of that. But then we forgot till that time, till at least 1999, we didn't look at from a space side for national security. Kargil war came, so this was the first time that we thought we should do something for the national security. So in 2 years' time, we made a new satellite called Technology Experiment Satellite, when we could give our defense forces what's happening across the border with a 1-meter resolution. So that was the first time in 2001 when we made this satellite. And from there, we have got a lot of programs to support our defense in terms of remote sensing. Sometimes the press calls it mischievously spy satellites and all that. But it's a part of the game, so that happens. Now, coming to future, when in 97 we were just debating the same sentence of Sarabhai, which he had made in 1967 in UN, in which he said, advanced technology for man and society. He had also said that we have no ambition of going to beyond Earth, going to asteroids, going to moon and all that he has said. But then we were debating that if Sarabhai is alive in 97, 30 years later, what he would have thought? And we sincerely believe that sentence of Sarabhai, or guideline of Sarabhai, or mission of Sarabhai in 1967 was no more sufficient. So we decided that we should go for Chandrayaan-1. It was a national level debate. We involved hundreds of agencies to see public opinion. We organized various meetings of scientists. From everywhere, the word came, yes, we must do it. And that's how the Chandrayaan-1 was evolved. We also decided that we should do re-entry exercise, because if the man has to come to Earth, we have to re-enter. You know, when satellite is in orbit, its velocity is approximately 7.8 kilometers per second. You can understand, 7.8 kilometers per second. So when it enters the atmosphere at around 100 kilometers, then the atmosphere air drag creates a lot of heating. So it has to stand that heating, and you have to have a proper control. It should not get aerodynamically unstable. So there's a lot of technology related to the re-entry. So we did a mission on re-entry. So this is all happened in the year 2005, 2006. Of course, personally, when I was director of ISRO Satellite Center, I was there for 8 years, from 1997 to 2005. I was asked that I should go to Delhi as a Secretary Government of India. And there was a thought that we need to create a new ministry, Ministry of Earth Science. It was a difficult task, because reorganizing a ministry in a setup which involves multidisciplinary, multi-departments activities. So I did that job for 3 years, including things like tsunami warning system, looking at how to improve the weather forecasting, and many other related things with respect to the Ministry of Earth Science, including ocean, how to get the water from the ocean, or how do you get deep into the ocean, what are the problems related, engineering challenges. And that kind of exercise still continues in different sense. But then 6 years after that, I retired in 2008 and spent 6 years. Again, went back to the defense. And those 6 years, largely, again getting back to how space can serve our national security. I was a member of the National Security Advisory Board and Chairman RSC and all that. So we created a system now in DRDO. There's a lab in Hyderabad. We engage about 200 engineers who really look for what we can do, how space can help creating new satellites and all that. So I'm not getting, again, back to technical details, but the issue is that got into a few other things like looking at overall engineering aspects in the country. There's a body called Indian National Academy of Engineering. And I had as president for 4 years to look at, organize how engineering, what engineering is doing and can do for the country. Again, there are a lot of issues which are pending. Why we are not successful in many areas. Just to give you an example. there is a area called Sundarban in Bengal, West Bengal. Actually, we had only around 1/3, 2/3 is with Bangladesh. It's a area which is practically no activity, fishermen, only fishing activity. But when you look at Netherlands, you will find a lot of similarities. Netherlands has become Netherlands because they reclaimed that area which was below the ocean level. And in fact, I had organized a study that what engineering interventions have been done in Sundarban ever since. We found that in 1944 there was a British engineer who brought sweet water to Sundarbans. Even after independence in 47, nothing has been done. We have not done that transformation. We can transform Sundarban like Netherlands. We have that potential. There are many things. Similarly, we are doing good job now, let us say, with the defense aircraft, Tejas. All of you are aware. But actually, Tejas is maybe 20 years old technology. In fact, Tejas came out of the roll out in 98, Dr. Kalam brought out. So that itself is 25 years. What next? We are at least 15, 20 years behind in fighter aircraft. Civil aircraft. Today, we are number 2 civil activity in terms of civil aviation activity in the world. And we have how much? 36% growth now last year. But we don't make a civil aircraft. So there are many things which are not happening, which should happen. So there are a lot of questions in front of the engineering community, science community, that many things they were supposed to happen have not happened. And always one bothers about it. Why I am raising these questions to you, to youngsters particularly, that don't assume that everything is done. No. Actually, most of the things are not done. There is opportunity. And when you say that how do we get into, as I said earlier in my starting point, you have to choose your next step. Don't think of becoming Sarabhai, or don't become a astronaut right when you are at the age 10 or 12 or 16. You have to choose your next step. So it's a step-by-step process. But you have to make one commitment for yourself. And the commitment you have to make is that if you are a scientist, if you are an engineer, you have to make some difference to the site and to the life of the people for easing the life. In what way, it doesn't matter. One more clue I want to give it to you is that you do not become a big scientist or a big engineer by doing big things. You become a big engineer by doing small things. Small things with understanding. Today, you can do a lot of things using software tools, but you have no idea how it works, then you cannot do the real things in life. You have to appreciate, understand. My mentor, Professor Yoro, used to say that most of the people do not understand Ohm's law or Newton's laws. We read all of them, we can narrate them, but actually the complete rocketry or even satellite science, actually is governed only by Newton's law. We don't need relativity or quantum physics for that. All things is governed by Newton's law. But do we understand Newton's law? So, question is, you have to give much more priority to understanding what you do. And then take a commitment that you will make a difference. I'll just complete my narration with one small, again, story, which is sometimes I remember to tell students. I saw a documentary film. And documentary film is about a writer. To take inspiration, he just thought that he'll go to the beach and just watch. And he was watching, he found a young man walking along he was just sitting there, walking along the beach, and the young man was picking something from the water, just coast, and throwing back into the water. He could see from distance what it is. He was a bit puzzled what this boy is doing. Next day he went at the same time, same thing repeated. So third day he decided to talk to him and find out. So third day when he went and this boy was picking up, he went to him and said, "Look, what are you doing?" He said, "I'm picking this jellyfish and throwing back into the ocean. Because if he's not thrown, it will die." This writer was a bit knowledgeable person. He said, "Look, what nonsense you are talking about. India has got 7,500 kilometers of coastline. World has few lakhs kilometers. You will walk a kilometer or two and save this. Do you think it will make a difference?" This young boy didn't say anything. He just picked up the next one, threw into the ocean, and he said, "It makes difference to that one." The point is, the difference you will make is not important how big it is. It is important that you make a difference. So you have to take a commitment of that. Second thing, I would just like to talk to you because I also have another responsibility. I am chairman of a body called National Innovation Foundation. Now, what is innovation? Innovation is not creating new science. Innovation is not creating new things by new principles. Innovation is something creating a new product, new idea, which actually makes use of existing knowledge. So we are not looking for a new knowledge, but we are looking for making a difference. Making a difference using existing knowledge. And that's why I say that everybody cannot become a scientist, but everybody can become an innovator. So the thrust Prime Minister is giving for innovation is because of that reason. We need to innovate in our day-to-day life. And there are hundreds of ways of doing that. So that we can discuss when we get into details. But this is what the message I wanted to give you. And feel free to ask any questions related to science and technology. Don't get limited to just space or anything you like. Okay, thank you.
You have explored your journey from just childhood to your career. And we firstly really wanted to start with this only, but you already explored your childhood, your school education and all. So we'll start with the education system at your time and the present education system. How you compare or how you can give the value addition.
See, when I started my education, it was, my schooling was, as I said, in the 60s and so it was a very much structured system. You cannot deviate. You have no choices. And when I shifted from UP to Rajasthan for my higher secondary, I found the distance was quite different in the sense that whatever, the mathematics in UP was much more stronger. What I studied in 8th was being taught in Rajasthan in 9th. So that way I had some advantage also. I started my English learning only ABCD in 6th standard. So in that sense, it's quite different. And it is, for example, in 9th class, I had only 2 choices or 3 choices: commerce, PCM or PCB. M for maths and B for biology. That's all. That is the only choice left. So there were not many choices in that sense. Advantage, you don't have to think much because anyway, this is a straight jacketed system. You have to really go with that. Today's system is slightly different in the sense that the way NEP is planned, the NEP's purpose is actually, is really designed by Dr. Kasur Rangan, who was my boss as Associate Center Director. So I'm to some extent aware of that. The idea is that we are trying to create a kind of a feeling in our young students that their study is not just a study. Study is to do something important in your life. And you try to make a goal that you will make a difference in the field you like. I'll give you the difference. When I studied my BE, it was MBA Engineering College, Jodhpur. My teachers were very good. But then our understanding was limited to the coursework. When I went to Indian Science for my master's, I would say the teachers were not as good as my teachers in MBM. But the vision was very different. The ambience at ISC gave a lot more thinking about research. When I was at MBM, I never thought of what is research. But the moment I entered ISC, the idea was, B is nothing. IME is also nothing. You have to do research, you have to do something new. So this transformation. So the way I understand the new education policy essentially tries to give the message of transformation to the young children, young boys and girls at early stage. It has got advantages, but it has got disadvantages also, the way I perceive. See, advantage is that the one who are really bright ones, they give them directions much earlier and all that. But then the competition it creates sometimes is too strenuous to the children. So I'm sure the balance will take place automatically, but sometimes that's the feeling I have. But otherwise, its idea is to grow more naturally in the area. There is a natural instinct exists, which probably was not there earlier. And also the choices you give when you look at the engineering, you have a lot more choices and you have a lot more choices to jump. If I'm not doing very good in mechanical engineering and I feel I can do better, let's say in computer science, I can do that, or other way, vice versa. So this kind of choices, they give you some kind of a mid-course correction to do the things to your, I would not use the word liking, but what you are suited for. See, everyone has got some kind of a intuitive strengths. So one can choose as per his strength or her strength. So that's the way I perceive.
What I understood is the education system at your time it was the self-motivating learning, more focus on the self-learning. And nowadays it is more towards the privileged learning. Everything is ready, platforms are ready. So if there is the add-on of self-motivation, the things can be happen, or what is the progress?
That perception is not correct. See, I'll tell you why. See, even if in my generation, if I'm self-motivated, what I can do? There's no internet, no computer, no books. In fact, the only book available to me till my higher secondary or even to engineering is the book which is there in the course. Beyond that, there's nothing. Library also will have only those books which are available for the course. Today, there is a lot of choice. Even a young student of 5th standard goes to internet and looks at what is the map of the country, and he says, no, my book is faulty. So, if you are, what you said, self-learning and all that, today is much more opportunity. In my time, there was no opportunity. What will you do? Even if I want to do something, there is no facility available. So, I would say it was more straight-jacketed that time. Today, it opens up much larger way, because there are opportunities. And also, I would say that because the children are going in a different environment. So, they are sharper than probably we were at our age.
Sir, how you will relate science, engineering and technology?
Next. You said next, huh?
Next question.
You see, there's a different era if you look at the development of, I would say, particularly technology. See, science is a very different. Let's look at science first. The major contribution in science happened by Isaac Newton. And in that period, there was a few more, but 500 years back. And for almost 400 years, nothing very significant happened in terms of science. Then we had Einstein, and then we got a real new thing in terms of special theory of relativity. Now, it made a difference when we are looking for things which are running at speed of light, and gave a much more direction in terms of understanding universe, better than what we were doing with Newton's physics. I would call Newtonian physics. Then, simultaneously, there was emergence of quantum physics. Now, quantum physics matured probably in next 50 years by about 1960. This maturity actually gave us understanding at microscopic level. It's more atomic, subatomic particles and all that. So that was a science development. If you really see, in the last 60 years, nothing revolutionary has happened in science after quantum physics. Quantum physics was the major revolution in science in terms of understanding. We are talking of, let's say, string theory or general superstring theory, where we are talking of a combined various force. But that is still, I would say, a lot of research going on, but there is no convergence. We still do not understand the fundamental nature of the particle. So that is one part. So science is a one place. Engineering is a very different story. Engineering, if you take the century before, let's say, 19th century, there was a lot of development in materials. And the biggest development was the invention of railway engine, because that was the major thing. When you come back to the last century, the first revolution was the development of aircraft. That was the biggest engineering thing. Then later, the invention of transistor. That started big difference. Then transistor, it was actually a bulk transistor with a, you can say, the junction would be of the order of 100 micron or so. But then it became a micron, 1 micron, sub-micron. Today we are talking of a technology that has grown to something like 3 nanometer. So this revolution which has taken in the last 60 years is mostly guided by the so-called transistor. It's no more a transistor, it becomes a, you get a few gigadevice in a chip. This revolution has changed. The question is now, what will change next? What one expects is that the human intelligence is not able now to gather all this together. So the next revolution you expect for next 20 to 30 years is going to be the so-called machine learning and artificial intelligence. So this is the area which will really give a new direction as far as engineering is concerned. Of course, there are other areas like some materials development which are taking place. For example, when you take solar cells, energy. In energy, the development of materials is going to make a lot of difference. We have seen, you know, that solar power, it remains constant. We started using solar power in satellites from, let's say, 50s onwards. And the price of solar power remained constant almost the next 50 years. But in last 20 years, it has sharply come down, and has come down to by a factor of 20 already, what it was. So this is where it will go down further. So there are, in the area of energy, there are going to be a lot of revolution. It will be driven mostly by transportation, and also because of global warming, there's a lot of focus on energy, alternate energy. So these are the areas in which you will see big changes coming in next 20 years or so. And these changes will also drive other applications, I would say including the war. It's very likely that 20 years later, it won't be human fighting, it will be fighting either robots or UAVs. So those are the areas where you are going to see revolutionary changes in the technology.
So, in your speech, sir, you talk about the fundamentals, aptitude, and application. So, can we relate science as a fundamentals, engineering as aptitude development, and technology as an application?
No, they are all related. An engineer cannot do a good engineering unless he understands science. For any engineer, the physics is the mother. In fact, there is a debate goes on, a lot of debate, whether mathematics is the fundamental science or physics is the fundamental science. To me, physics is the fundamental science. Mathematics helps me understanding physics, because I cannot understand, let's say, things like relativity or even Newton's theorem. If I have Newton's gravity law, if I have to understand fully, I need to know calculus. Without calculus, I cannot derive the equations. So mathematics to me is a tool. Physics is very fundamental. And without understanding physics, I cannot be a good engineer. And if I'm not a good engineer, I cannot be a good technologist. So to me, it's all related. Ultimately, it goes back to physics. So if one says that I'm an engineer, I don't understand physics, then you are not good engineer.
So to understand the technology, fundamentals should be clear.
Fundamentals of physics should be clear. Actually, I would say this way.
Sir, being an electrical engineer, as you said, become engineer by doing small things. So everyone cannot be a scientist, but you can become an innovator. So can you differentiate between scientist and innovator?
Yeah, I explained to you. See, when you say I'm a scientist, then I'm trying to find new knowledge. Because, see, how do you judge scientists? You judge scientists by publications. Yes. Okay, publications means if you have, and there are also type of journal. Yes. If it is a journal like, suppose you are talking of in physics you are talking nature, if you are talking engineering, electrical engineering, you are talking IEEE transaction. If you publish a paper in IEEE transaction, then you have done something very good in engineering aspect, but in terms of doing something new, science, new knowledge, because IEEE will not publish a paper unless there is new knowledge in that. Okay, so that's part. Whereas when you are talking something new, in terms of innovation, you are not necessarily using any new engineering or new knowledge. You are using existing knowledge. So when I say existing knowledge, and normally innovation now comes with the combination of different knowledges, different fields, multidisciplinary. See, when we say you look at any Chinese toys, you will find that there's a lot of things happening in that which comes either from the Either he is using LED, he is using electromagnetism, he is using various things and then making a toy. So this is not research, it's an innovation, because he makes use of existing knowledge. So when you say innovation, there is no dearth of, you can say, products. You go on, imagine you can do hundreds of new things. So that's why the focus now, see, when we really say we go to market, we find all Chinese things, because they are very innovative. And of course, innovation also related to the doing innovative things at cost-effective manner. If the cost is more, it's of no use. So innovation is actually making use of existing knowledge in multidisciplines. Not one, multidisciplines. And coming out products which are better. See, whenever you find a new thing happens in home, or a child comes with some idea, you see it's very innovative. So idea is that only. A child comes up with new ideas. In fact, we are trying to say at different levels. Prime Minister is trying to create the so-called innovation hubs or Atal Innovation Labs in many institutions. His idea is that only, that the students should start thinking what new they can do. Innovation is start thinking, okay, can I improve this product? This is a product, I'm using a mobile. So actually a person who is a mobile fellow, he starts thinking, how can I improve its performance? He doesn't do any new knowledge into that, but he makes use of existing knowledge. Somewhere someone has developed some new software, he'll try to adopt the software into his mobile. You see, when Apple was started by Steve Jobs, what he did was, he tried to actually collect a lot of people who were artists. And he was the first person to have these icons and all that, you are laughing, you are smiling, or all that, he did that. So he actually became famous in Apple because he brought the discipline of art into mobile. That's how Steve Jobs is. I mean, he always used to say that creativity is not something in the same field unless you really mix many areas. So idea of innovation is that you use a multidisciplinary science or multidisciplinary knowledge which is existing. Whereas research is very different. Research, you are getting a new knowledge.
Novelty should be there.
No, novelty can be in innovation also. Novelty is a very common word. No, actually, innovation looks for novelty.
Yes.
Whereas research is not novelty. Research is something advanced knowledge. Advancing the knowledge is research. Whereas innovation, you are looking for novelty. So novelty is associated with the, innovation.
Thank you, sir. What motivated you to make a career in space technology? That means who is your role model, or what is the inspiration behind that?
Frankly speaking, when I was doing my master's, so there were 2-3 options. In the sense that in those days, I did 1970, everyone was, the craze was to go abroad. And particularly at Indian Institute of Science, everyone was going abroad. But somehow, because of my some association with some people and all that, I decided not to go. Then I was looking for a job, so there were 2 things came. One was teaching and another was ISRO. So I got both the jobs, but then there was my teacher, one Professor Bansal. So I met him. And I went to him and I said, look, sir, I have got this job for teaching. Then he said, okay, do that, but in teaching, you will be, let's say, promoted based on your seniority.
Yes.
And ISRO, I don't know. So I said, whether I'll go to unknown place where I have some more opportunity. I didn't want to get promoted based on seniority. So it's as simple as that. There's nothing very, I mean, in those days, we have heard about ISRO, particularly rocket. So idea was there that, okay, so there's something new. But what really, why I didn't go for teaching was a simple reason that my professor said that you will be promoted only by seniority. So I didn't like that.
Thank you, sir.
Okay.
Sir, it is really a great journey that from scratch to scientist. Being a young scientist, what challenges you faced?
Well, my challenge is very simple. I had no guidance. I started my subject for the first time in country myself. So, whatever I had to do myself, number one. And then, of course, slowly I built up a team. That's a separate issue. I started with one, but then later we became more and more people. But then, in this satellite technology, because we were evolving, so we were seeing what others are doing, particularly the Americans. So we were trying to see how we can adopt what they are doing, which can help our people. So particularly in remote sensing area. We made Aryabhatta. Aryabhatta was only scientific satellite. Then our professor said, can we make it remote sensing satellite? So I talked to some of the people who were developing payload in Space Application Center, Dr. George Joseph, and we developed a technique that how can I make a spinning satellite, a remote sensing satellite. No one in the world has done it. But our urge was to do remote sensing with a minimum changes in minimum time to make a remote sensing satellite. Similarly, after that became Aryabhatta 1 and 2. Then we decided that the Landsat C and D by NASA, they were making a very big, you can say, name in the remote sensing area. So we decided that we will develop a satellite which is as good as the Landsat D. So we started working on the IRS satellite. Now it has a lot of challenges in terms of control system. It will be too difficult to explain that in a short forum because it's a thick stabilized satellite. See, you imagine when you take a photo, if your hand shakes, you will not get a good photo. And what is the distance of your, when you're taking photo? Maybe 10 feet, 15 feet. I'm taking picture in IRS satellite from 750 kilometers. So if I have to take picture from 750 kilometers, if there is a small motion in the picture taking time, what will happen? It will be smear. I will not get picture. So I have to control the satellite in such a way that from that distance, I take a clear picture. Now that was a challenge. So like that, and we had we only knew that Landsat is doing. But Landsat is also not using this technology. They were using different technology. So we had to find these solutions ourselves. So our challenge is actually in every new satellite, as I said, Aryabhatta to Bhaskara, Bhaskara to INSAT, IRIS 1D, IRIS 1C to Apple, Apple to INSAT 2, or then we went to satellite for ocean set thing. Then we made a separate satellite for studying the sun. So every satellite, then we made a satellite to look at the stars. Our scientists wanted to look at the stars with a very, they said, I want to look at the same star for, let's say, 10 days. Because star signal is very low. If you are familiar with the noise cancellation, if you go on integrating, the noise gets cancelled, signal starts coming. So those all things were totally new for us. So I would say that my life has been fruitful because I could do new things for every new satellite. Maybe the younger generation, probably they also find a way to do new things, but they will not have that many opportunities.
Within such a limited resources, you have faced such challenges and find the solution. That's really great. Next, sir, from audience, behalf of audience, I'll ask this question. You have many milestones in your life, which are memorable or most rewardable according to you?
Actually, there were many, if you really look at it. Okay, the first was, when I was working on Aryabhatta satellite, I was very young at that time, the Bhaskara satellite. So we had to orient the satellite in a direction where it can take a picture from the Earth. And it was a spinning satellite, so the mathematics was telling something else, and common sense was telling something else. So I was in a dilemma whether my common sense is right or mathematics is right. And I had no guidance. So actually, it's like this. You have seen a pot maker, no? Kumhar, chakki hoti hai uski. You've seen that running? Now, you imagine that wheel is running very fast. Now, suppose you hit like this. What do you expect? How will it tilt? A so-called chalk, Hindi बोलते हैं ना, chalk. उसको आप hit करो. What will happen? You hit it like this. What will happen? Anyone can answer? बोलो बेटा. What will gyroscopic effect do? How? Tilt which direction? Tilt which direction? You are right, gyroscopic effect. Okay, word is right.
सर कुछ ऑडियंस से ऐसे आया है कि
हाँ.
हिंदी में बात कर सकते हैं.
अच्छा अच्छा हाँ.
दैट
ठीक
इज
है.
कंफर्टेबल फॉर देम.
सॉरी. जब आप वो चाक होता है कुम्हार का, वो घूम रहा है, उसको आप ऐसे हिट करो एक साइड से, क्या होगा? वो आप सोचेंगे ऐसे टिल्ट होगा, ऐसे नहीं, वो ऐसा टिल्ट होगा, 90 डिग्री टिल्ट होगा. आप मारेंगे ऐसे, वो 90 डिग्री टिल्ट होगा. तो दैट वाज माय प्रॉब्लम. मैं उसको कैसे सॉल्व करूं? तो हमको उसका हिसाब, खैर आपका चाक नहीं करेगा क्योंकि नीचे से वो हिंज होता है. यदि वो फ्री है मूव करने के लिए तो 90 डिग्री जाएगा, वो जायरोस्कोप बोलते हैं. तो उसको हमको लगा ये कैसे हो रहा है, मैथमेटिक्स वो कर रही है. अब उस हमारे पास ऐसा कुछ था नहीं जो बिल्कुल एयर में हो, उसके नीचे कहीं सपोर्ट नहीं होता, सैटेलाइट में कुछ सपोर्ट नहीं होता है. तो हमने एक बेयरिंग बनाया, एक 10 इंच का, उसमें बॉल बनाया एक 10 इंच का, उसमें एक कप बनाया और उनको फ्लोट किया, उसका एयर गैप से फ्लोट किया 25 माइक्रोन. फिर हमने एक्सपेरिमेंट किया और हमको लगा कि हमारा मैथमेटिक्स करेक्ट है. तो एक वो था. दूसरा एक था कि हमारा भास्कर सैटेलाइट, उसमें कुछ थोड़ा प्रॉब्लम हो गया था. तो हमने 6 महीने तक उसको स्टडी किया, बंद कर दिया सैटेलाइट को, उसको पेलोड नहीं किया. फिर 6 महीने बाद हमने उसको फिर स्टडी किया करके उसको हमने जब ऑन किया दोबारा, तो हमारा बहुत सारे कन्फ्लिक्ट्स थे, ये करें वो करें. और उसमें हमने एक वो निकाला कि हाँ ये पहले ये करेंगे, और मैं जैसे ही वो किया वो काम करना शुरू कर दिया. तो एक ऐसा वो मोमेंट था. ऐसे ही हमारे एक एप्पल सैटेलाइट, उसमें एक सोलर पैनल नहीं खुला था, और सोलर पैनल नहीं खुला था उसकी वजह से हम उसको कंट्रोल नहीं कर पा रहे थे. और उसको हमारा एक दिन उसको जो शुरू का कंट्रोल था वो केवल 6 बजे मॉर्निंग में करना था. तो पहला हमारा दिन चला गया, नहीं हुआ. हम कोशिश किया, दूसरा दिन चला गया, नहीं हुआ. तीसरे दिन भी हमने 2 अटैम्प्ट किए, नहीं हुआ. और एकदम से हमारा एक इंजीनियर बोला कि सर ये जो अभी आपने एक्सपेरिमेंट किया इसका रिज़ल्ट ये रहा. वो एकदम से दिमाग में आया कि अरे हमने एक गलती कर दी. और हमने उसको फिर दोबारा से तीसरी बार जब किया, हो गया. तो कई बार ऐसा होता है कि एक फ्लैश आता है, आपके दिमाग में सॉल्यूशन आता है. तो वो एक तरह से फ्लैश आया, और वो उस दिन वो बहुत क्रूशियल था हमारे लिए, क्योंकि एक सैटेलाइट के पीछे आप सोचिए कि कम से कम 1000 लोग 3 साल तक काम करते हैं, और यदि वो काम नहीं करता है तो उसमें कितने पीछे लोगों का एफर्ट रहता है. तो उसको मुझे दिमाग में जो एक सॉल्यूशन आया एकदम से. ऐसे ही इंसेट 2 सैटेलाइट में भी ऐसा ही था. एक बार इंसेट 2 सैटेलाइट जब हमने शुरू में छोड़ा तो उसमें एक प्रॉब्लम आ गई थी. हमारा एक वाल्व था, वो लीक कर रहा था, और वो वाल्व का हाई प्रेशर एक टैंक में जा रहा था. अब यदि हम उसको 10 मिनट तक कुछ नहीं करेंगे तो वो टैंक ब्रस्ट हो जाएगा, और बस्ट हो जाएगा तो सैटेलाइट ख़त्म हो जाएगा. तो हमको कुछ सेकेंड्स में उसका सोल्यूशन ढूंढना था. उसको इम्प्लीमेंट करना था। तो ऐसे मोमेंट आए हैं लाइफ में जो जिससे लगा कि हाँ एक अच्छा हो गया। तो ऐसे कई हैं।
हम थोड़ा हिस्ट्री की तरफ मुड़ते हैं सर। भारत का पहला सैटेलाइट जो है आर्यभट्ट, बीइंग पार्ट ऑफ दैट टीम, यू वर अ पार्ट ऑफ दैट टीम, तो आपका अनुभव कैसा रहा?
जो आर्यभट्ट था वो उसमें थोड़ा सा हमको प्रॉब्लम ज़्यादा इसलिए नहीं आया, हालांकि उसमें काफ़ी सिस्टम हमारे थे, पर वो एक तरह से रशियन कोलैबोरेशन था, तो उसमें कुछ सिस्टम्स रशिया से भी आए थे। तो उसमें ये हाइब्रिड था और हमारी जॉइंट मीटिंग्स भी रहती थी। लेकिन जब हमने उसको सैटेलाइट को लॉन्च किया तो उसमें सब कुछ काम किया ठीक, और पहली बार ऐसा बड़ा वो वक्त है। आप देखिए ये बात है 19 अप्रैल 1975 की। उस समय देश में पिन भी नहीं बनती थी, सब कुछ इम्पोर्ट होता था, और देश में ऐसा कॉन्फिडेंस नहीं था कि हम कुछ कर सकते हैं। तो सैटेलाइट काम किया वो अपने आप में बड़ी बात थी। दूसरे उसका एक जो पेलोड था उसका एक पावर सिस्टम, उसमें एक शॉर्ट आ गया था, तो एक्चुअली वो पेलोड काम नहीं करे, तो वो अपने आप एक सेटबैक भी रहा। लेकिन उस सैटेलाइट को आर्यभट्ट की वजह से मैं उसको क्या कहता हूँ कि हमारे देश में बहुत बड़ा कॉन्फिडेंस आया। ये जो आईटी टेक्नोलॉजी बाद में आई, जो बहुत सारी चीज़ें, देखिए 2 लैंडमार्क डेवलपमेंट इस कंट्री में किए उस एरा में। 74 में पोखरण 1 और 75 में आर्यभट्टा। ये 2 ऐसे लैंडमार्क थे जिन्होंने कंट्री को कॉन्फिडेंस दिया है कि हम लोग ऐसा एडवांस टेक्नोलॉजी कर सकते हैं।
करेक्ट।
सैटेलाइट आर्यभट्टा बाय इटसेल्फ तो बहुत सिंपल था आज के ज़माने में देखो तो, लेकिन उसके ज़माने में देखो तो एक बहुत बड़ा स्टेप था एट दैट टाइम।
थैंक यू सर।
इनफैक्ट टेक्नोलॉजी देखो तो आर्यभट्टा से भास्करा में बहुत ज़्यादा चेंज आया, भास्करा से IRS में और भी बहुत ज़्यादा चेंज आया, लेकिन आर्यभट्ट को उस टाइम करना वो अपने आप में बड़ी बात थी। आर्यभट्ट ने बेच दिया हमको।
करेक्ट।
इसरो का आपका इतना सारा एक्सपीरियंस, इतने सारे अचीवमेंट, एंड देन द अपॉर्चुनिटी ऑफ मिनिस्ट्री ऑफ अर्थ साइंस, हाउ वाज योर माइंडसेट टू मूव फॉर दिस ट्रांजिशन फ्रॉम इसरो टू मिनिस्ट्री ऑफ अर्थ साइंस? आप कैसे, क्या आपका माइंडसेट क्या था जब आपको मिनिस्ट्री ऑफ अर्थ साइंस का अपॉर्चुनिटी आया?
एक्चुअली ये भी एक अजीब सी इंसिडेंस है। मैं सैटेलाइट का सेंटर का डायरेक्टर था ऑलमोस्ट 8 साल, और मेरे दिमाग में हमेशा रहता था कि अब कुछ नया करना चाहिए, क्योंकि एक किसी भी, मेरा ये मानना है कि किसी भी इंस्टीट्यूशंस को आप एक तरह से डायरेक्शन देते हैं तो उसके लिए 5 या 6 साल आइडियल है। 3 साल से कम होगा तो आप कुछ नहीं कर पाएंगे। आप अपने आप को जब तक समझते हैं बड़े इंस्टीट्यूशन को तब तक टाइम लग जाता है, और यदि 5-6 साल से आप ज़्यादा रहते हैं तो आप एक तरह से स्टेबलाइज हो जाते हैं, कंफर्ट हो जाता है, आप कुछ नया नहीं करते। तो मेरे दिमाग में ये था, एक बात घुस रही थी कि अब मैं जो भी मुझे करना था इस इंस्टीट्यूशन में वो मैं कर सका हूँ। सैटेलाइट को मैंने बहुत सारी चीज़ें दी, डायरेक्शन दी, तो एक वो बात थी। फिर एक हमारे एक बहुत ही रिस्पेक्टेड प्रोफेसर ISC के हैं, थे, अब नहीं रहे वो, एरोनॉटिक्स में उनका बहुत बड़ा नाम है, प्रोफेसर रूडम नरसिम्हा। वो मेरे पास आए और बोले कि डॉक्टर गोयल, आपको एक अपॉइंटमेंट आएगा। मैंने कभी अप्लाई नहीं किया, मुझे पता भी नहीं था। बोले आपको ऑर्डर आएगा कि आप डिपार्टमेंट ऑफ ओशन डेवलपमेंट के सेक्रेटरी अपॉइंट हुए हैं। बोले आप इसको मना मत करना। तो मैंने कहा सर आप क्यों, ओशन डेवलपमेंट से मेरा कोई मतलब नहीं है। तो बोले कि हम चाहते हैं कुछ साइंटिफिक कम्युनिटी कि जो ओशन डेवलपमेंट है ये ओशन है, और ओशन और एटमॉस्फेयर ये कपल्ड हैं। यदि आप मेट्रोलॉजी को फोरकास्ट करना चाहते हैं, जैसे वेदर फोरकास्ट करते हैं ना, वेदर फोरकास्ट को खाली आप एटमॉस्फेयर को देखेंगे, एटमॉस्फेयर की स्टडी करेंगे तो आप करेक्ट नहीं कर सकते। आपको ओशन को देखना पड़ेगा, ओशन टेम्परेचर, ओशन कपलिंग, ओशन प्रोसेसेस, ये सब उसमें कपल रहते हैं। तो वो मेरे से बोले कि हमको ओशन और एटमॉस्फेयर ये आज की तारीख में अलग थे बिल्कुल उस समय, तो बोले इनको कपल करके एक साथ देखना है, साइंटिफिकली इनको टुगेदर करना है। ऐसे ही कुछ प्रोसेस जो अर्थ के हैं वो भी ओशन और एटमॉस्फेयर से कपल रहते हैं। तो आइडिया ये था कि इनको करना है, और मेरे से बोले बहुत कॉम्प्लेक्स टास्क है, ये होगा नहीं। तो बोले आई नीड यू, और वी नीड, इनफैक्ट यूज द वर्ड वी नीड यू टू गो टू दिल्ली एंड क्रिएट मिनिस्टर फॉर साइंस। तो जैसे मैंने बताया, मैंने अप्लाई नहीं किया, पता भी नहीं था मुझे, तो मुझे ऑर्डर मिला और ये उनका क्रिएशन था। तो मुझे लगा कि एक अपॉर्चुनिटी है कुछ और नया करने के लिए, और मैं समझता हूँ कि मुझे बहुत कुछ सीखने को मिला वहाँ पर। जब मैं दिल्ली गया तो पहले जब मैं इसरो में था, खाली इसरो का था, मुझे नहीं पता था कि डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी में क्या हो रहा है, बायो टेक्नोलॉजी में क्या हो रहा है, और दूसरे जो एरियाज़ हैं इनमें CSIR में क्या हो रहा है। दिल्ली के उस 3 साल का जो मेरा पीरियड था उसने मुझे बड़ा ब्रॉड पिक्चर दी, यहाँ तक कि गवर्नमेंट कैसे काम करती है। इसरो में हम बिल्कुल आइसोलेटेड थे। अब जैसे मान लीजिए कि आप एक टीचर हैं, जब तक आप प्रिंसिपल नहीं बनते आपको नहीं पता कि उसका डायमेंशन, आप पढ़ाते हैं ठीक है, तो ऐसे ही गवर्नमेंट कैसे काम करती है जब तक आप सिक्योरिटी लेवल पर नहीं जाएंगे तो नहीं पता लगेगा। तो बहुत कुछ सीखा इससे। तो पर ये एक आप कह दीजिए ये भी एक लाइफ का टर्निंग पॉइंट था, इसके बारे में मैंने नहीं सोचा था।
ओशियन सरफेस मींस समुद्र का ऊपरी इलाका, अंडर वाटर नहीं, ओवर वाटर, राइट?
नहीं, जो ओशन डेवलपमेंट डिपार्टमेंट था उस समय, उसमें ओशन का सारा काम वहीं होता है। तो हमने उसके साथ में एटमॉस्फेयर को कपल किया है, और उसमें ये नहीं कि खाली सरफेस है, सरफेस अफेक्ट्स मैक्सिमम, क्योंकि इंटरेक्शन जो एयर का और ओशन का है वो सरफेस लेवल पे होता है, लेकिन वो सरफेस लेवल पे जब होता है तो वो नीचे वाले अफेक्ट करेगा। तो उसमें ग्रेडियंट्स कैसे डेवलप होते हैं वो सब कपल्ड उसमें आता है। जैसे आप साइक्लोन होते हैं, तो साइक्लोन इज ए इंटरेक्शन ऑफ एटमॉस्फेयर इन ओशन, तो उसमें खाली सरफेस नहीं है, इट्स अ डीपर इंटरेक्शन।
Why I ask you this question, sir, कि अभी चाइना अंडर वाटर बहुत डेवलपमेंट कर रहा है, अंडर ओशन बहुत डेवलपमेंट हो रहा है, लाइक अंडर वाटर रास्ता बना रहा है। सो लाइकवाइज इज इंडिया इज लुकिंग टुवर्ड्स सच डेवलपमेंट? ऐसी कुछ
एक डेवलपमेंट हम कर रहे हैं, उसका नाम है मत्स्य 6000 प्रोजेक्ट। एक्चुअली मैं उसको चेयर कर रहा हूँ, उसकी बॉडी को। अब मैं हालांकि मिनिस्टर ऑफ साइंस में नहीं हूँ, लेकिन वहाँ मैं उसका कर रहा हूँ। ये नेशनल इंस्टीट्यूट ऑफ ओशन टेक्नोलॉजी है चेन्नई में, वो उसका लीड सेंटर है। और इसमें हम एक 2 मीटर का एक कैप्सूल है, जिसमें मैन होंगे अंदर, और उसको हम 6000 मीटर तक लेके जाएंगे, 6000 मीटर मैन बिल को। एंड दैट यू विल हियर 500 मीटर का हम टेस्ट करने वाले हैं मार्च में, अभी 24 में। एंड बाय एंड ऑफ 24 विल गो टू 6000 मीटर्स। सो वो सब काम चल रहा है। उसका जो लीड सेंटर है वो नेशनल ओशन टेक्नोलॉजी है।
यहाँ सर बहुत सारे बच्चे हैं, स्कूल स्टूडेंट्स, कॉलेज स्टूडेंट्स। सो अर्थ साइंस रिलेटेड वो क्या पढ़े, या अर्थ साइंस में उनको कुछ करियर अपॉर्चुनिटी हो या कुछ करियर करना हो, तो हाउ दे कैन मूव?
नहीं, मैं यही कहूँगा कि अब मुझे नहीं पता किस लेवल पे हैं ये, एकदम से ये सोच करके अर्थ साइंस में करियर लें। मैं यही कहूँगा कि इनका नेक्स्ट स्टेप क्या हो, क्योंकि आज की तारीख में अपॉर्चुनिटीज़ बहुत ज़्यादा नहीं है। इवन अर्थ साइंस में भी बहुत ज़्यादा अपॉर्चुनिटीज़ नहीं है, क्योंकि हम कितना इंजीनियर लेते हैं साल के, मेरे ख्याल से 10 या 15 इतने ही लोग लेते हैं हम लोग। तो हम कहें कि बच्चों के लिए बहुत ज़्यादा अपॉर्चुनिटी, अनफॉर्चुनेटली हमारे साथ जॉब चैलेंजिंग है, लेकिन जो ओपनिंग्स हैं गवर्नमेंट सेक्टर में वो ज़्यादा नहीं है। ज़्यादा ओपनिंग्स है प्राइवेट जॉब्स में, तो उसको देखना पड़ेगा। अब जैसे शिप बिल्डिंग है, शिप बिल्डिंग जो बहुत बड़ा बिजनेस होने वाला है, हमारे कंट्री ने बहुत प्रोग्रेस किया है पिछले ऑलमोस्ट 10 साल से, तो उसमें बहुत अपॉर्चुनिटीज़ होंगी। तो हमको देखना पड़ेगा कि उसमें भी अर्थ साइंस तो बहुत बड़ा फील्ड हो गया, उसमें कहाँ, यदि आपका इंटरेस्ट है वेदर रिलेटेड थिंग्स, तो उसके लिए बहुत सारे इंस्टीट्यूशंस हैं जिसमें आज मेट्रोलॉजी पढ़ाई जा रही है। लेकिन अगेन आप कहें कि उसमें कितनी जॉब अपॉर्चुनिटीज़ हैं, ऑन एवरेज मेरे ख्याल से वी मे नॉट बी टेकिंग मोर देन 50 साइंटिस्ट ए ईयर। तो जॉब अपॉर्चुनिटी बहुत ज़्यादा नहीं है, लेकिन वो चैलेंजिंग जॉब्स हैं।
Actually, the problems related this earth and science. Let us speak about the भूस्खलन, जो लैंडस्लाइडिंग होता है आजकल, वो बहुत कॉमन इशू हो रहा है। अभी भी कुछ 41 मजदूर अटके हुए हैं। सो ऐसे प्रॉब्लम्स डील करने के लिए हम क्या टेक्नोलॉजी डेवलपमेंट सोच सकते हैं?
देखिए, एक इंस्टीट्यूट है NGRI हैदराबाद में, नेशनल जियो टेक्निकल रिसर्च इंस्टीट्यूट। एक्चुअली मैं उसका रिसर्च काउंसिल का चेयरमैन हूँ आज 6 साल से। वहाँ हम जो लैंडस्लाइड की साइंस है पर्टिकुलरली, उसके बारे में काफ़ी रिसर्च करते हैं, अभी भी करते हैं। और ये जो उत्तराखंड में जो लैंडस्लाइड सब हुई थी, उसका सबका स्टडी रिपोर्ट वो सब है। क्या हुआ है, जो हिमालय का फॉर्मेशन है वो ओरिजिनली वहाँ पे ओशन था, और जो इंडियन प्लेट आकर के आई उसने ओशन फ्लोर को ऊपर कर दिया। और ओशन फ्लोर को ऊपर किया तो वो जो हिल है या जो भी कुछ हिल एरिया है वो इतना स्ट्रॉन्ग नहीं है, वो बेसाल्ट नहीं है, उसके बीच में लूज स्ट्रक्चर्स हैं। तो खासकर इस एरिया में वो जो स्ट्रक्चर है वो लूज़ हैं। तो उनको कई बार एडवाइस किया गया है कि आप यहाँ पर मल्टी स्टोरी बिल्डिंग मत बनाइए आप पॉपुलेशन के। लेकिन क्या होता है कि अभी जो कमर्शलाइजेशन हो रहा है उसकी वजह से, अब टूरिस्ट अट्रैक्शन बहुत ज़्यादा है उधर, तो उसकी वजह से कोई भी रूल फॉलो नहीं करता है और कोई गवर्नमेंट उसको फॉलो नहीं कर पा रही है। तो लेकिन सच्ची बात यह है कि जो एरिया है क्या नाम था उसका, वो वहाँ पे स्ट्रक्चर लूज है। वो कई बार बता चुके हैं कि वहाँ पर इतना पॉपुलेशन डेंसिटी नहीं होना चाहिए। जहाँ तक जो आप बता रहे हैं जो पाइप में जो लोग फंस गए हैं, इसका भी कारण सिमिलर है। देखिए, जब हम ड्रिलिंग करते हैं, बोरिंग करते हैं, इक्विपमेंट आता है, अब हर जगह हो रहा है। आप मेट्रो बना रहे हैं अंडरग्राउंड मेट्रो में यही हो रहा है कि आप कितने सारे ब्रिज को बनाया है हमने, लेकिन कहीं कहीं वो बहुत लूज़ रहा होगा, और जो लूज़ होने की वजह से जो भी स्ट्रक्चर बनाया है वो उसको सपोर्ट नहीं कर पाया है। अब इसमें दो इशू हैं। एक तो है कि हम बनाते समय, क्योंकि बीच में से गिरा है, आगे ठीक है, तो बनाते समय जो हमने उसको रेनफोर्समेंट किया था वो एडिक्वेट नहीं था। तो इसका मतलब है कि हमने उसको रेनफोर्स जो किया था वो उसको जो स्ट्रक्चर है उसको प्रॉपर्ली स्टडी नहीं किया। एक तो वो मिस्टेक है। जो हमारे पास कैपेबिलिटी है, लेकिन यही है कि जो कैपेबिलिटी है NGRI के पास में, जब आप कॉन्ट्रैक्ट देते हैं किसी को, वो कॉन्ट्रैक्टर उसको कॉन्ट्रैक्ट नहीं करता है कई बार, तो विदाउट अंडरस्टैंडिंग कि उसको बोरिंग करेगा तो प्रॉब्लम आएगी। एक तो दूसरा है कि आज हम उसको कैसे सॉल्व करें। आज सॉल्व करने में सबसे बड़ी प्रॉब्लम ये आ रही है कि जो हमने खुद स्ट्रक्चर बनाया था, जो आयरन डाली थी ब्रिज के लिए, वो खुद नीचे कोलैप्स हो गई हैं, और सबसे बड़ा जो ऑब्स्टेकल वो हैं। तो इसका कोई इजी सॉल्यूशन नहीं है जो इन्होंने लिया है कि पैरेलली एक और खोद दो, क्योंकि ये कब सॉल्व होगा कुछ पता नहीं, कभी वो ये मशीन ख़राब हो जाती है, कभी उसका ब्लेड टूट जाता है, कभी उसमें लोहा अटक जाता है। ये प्रॉब्लम आएंगी, और आएंगी इसलिए क्योंकि हम रोज नहीं करते हैं, ये ऐसा पहली बार हुआ है। 10 बार होगा तो 11वीं बार आपका सोल्यूशन ढूंढ लेंगे। तो इसके लिए यही है कि आप अल्टरनेट सोल्यूशन भी साथ साथ करो। तो जो दूसरा सोल्यूशन है कि भाई इसको फॉलो करो, लेकिन दूसरा कि उनको और पहले ड्रिल करके आगे से निकाल लो, वही उसका एक अल्टरनेटिव है।
प्रॉब्लम्स आते हैं, जो भी नेशन प्रॉब्लम फेस कर रहे हैं, ऑलरेडी गवर्नमेंट इज कॉलिंग फॉर द सॉल्यूशन थ्रू द कंपटीशन लाइक स्मार्ट इंडिया हैकाथॉन, स्टार्टअप इंडिया. दे आर सपोर्टिंग टू द यंग इनोवेटर्स for providing the solution and giving the foolproof solution. So that is already government has taken the step.
Actually, if you ask me, it's not really solutions. It's a creating capability. All these जो आपने बताया ना, जो इंस्टीट्यूशन आपने बताए हैं, पहले क्या था कि एक माइंड सेट था हमारे देश में कि गवर्नमेंट जॉब लिया और जो जॉब आता है उसको कर रहे हैं। अब क्या है कि हमारे बच्चों में ये हो जाना चाहिए कि हम क्या अलग से कर सकते हैं। तो ये जो इंस्टीट्यूशंस है, ये बच्चों में एक थिंकिंग दे रहे हैं कि हम कुछ और भी कर सकते हैं। सॉल्यूशन आएगा इनसे, वो ऐसा नहीं है, सॉल्यूशन तो बाद में आएगा। हाँ, एक एबिलिटी टू थिंक डिफरेंटली, दैट्स व्हाट मैटर्स।
सर, थोड़ा हम न्यू एजुकेशन पॉलिसी के बारे में बात करते हैं। नाउ इंडिया इज़ इम्प्लीमेंटिंग दिस पॉलिसी, तो आपके क्या एक्सपेक्टेशन है इससे?
देखिए, सही बात, मुझे जो पर्सनल व्यू है ये है कि इसमें कुछ बातें अच्छी हैं और कुछ बातें जो हैं केवल हाइप हैं। और ऐसा सोचना कि न्यू एजुकेशन पॉलिसी से एक बहुत बड़ा रिवोल्यूशन हो जाएगा, वो मैं ऐसा विश्वास नहीं करता। लेकिन मैं ये भी मानता हूँ कि न्यू एजुकेशन पॉलिसी से एक आपको अल्टरनेट सोचने का, अल्टरनेट करने का एक अपॉर्चुनिटी मिलती है। अच्छा, दूसरा ये है कि कई बार ऐसा देखा गया है कि एक आदमी ने एक फील्ड में एमएससी की और दूसरे, जैसे हमारा सब एग्जाम्पल है प्रोफेसर सतीश धवन। प्रोफेसर सतीश धवन ने यहाँ पर एमए फिजिक्स या मैथमेटिक्स की थी, और जाके उन्होंने पीएचडी की एरोनॉटिक्स में। वो उस समय इंडिया में पॉसिबल नहीं था।
हाँ,
कि आप एकदम से एक फील्ड चेंज कर लो,
फील्ड चेंज होती है।
आज ये न्यू एजुकेशन पॉलिसी उस आपको अपॉर्चुनिटी दे रही है। अच्छा, तो ये एक अपने आप में बहुत बड़ी व्यवस्था है। अब इसका इम्प्लीकेशन ये है कि आपको इंस्टीट्यूशन में वो कैपेबिलिटी देनी पड़ेगी। जो आपका जो भी इंस्टीट्यूशन है उसमें आपको, कि आप फ्लेक्सिबिलिटी दे रहे हैं, तो फ्लेक्सिबिलिटी आपको एनवायरनमेंट क्रिएट करना पड़ेगा। दूसरा ये भी है कि ऐसा नहीं कि हर एवरी चाइल्ड विल डू दैट चेंज और एवरी स्टूडेंट विल चेंज। अपॉर्चुनिटी जो है, जिनके पास एक्स्ट्रा कैपेबिलिटी है, जो अपने आप को सोचते हैं कि हाँ मुझे अलग करना चाहिए। आप इस बार कई बार देखेंगे कि जैसे मेरे कलीग हैं, उन्होंने मेरे साथ बीई की सिविल में, फिर एमई की मेरे साथ इंस्टीट्यूट साइंस में एरो इंजीनियरिंग में, तो सिविल से एरो में गए। फिर वो अमेरिका गए, उन्होंने पीएचडी की अकाउंट्स में, एंड ही बिकेम ए वेरी लीडिंग अकाउंट्स। उन्होंने अलग से एक अपनी वो खोली, फर्म खोली, एंड ही वॉज द लीडिंग पर्सन इन अकाउंट्स। तो ये जो अपॉर्चुनिटी कि आप एक फील्ड कर सकें, ऐसा चेंज कर सकें, ये न्यू एजुकेशन पॉलिसी प्रोवाइड करती है, जो उसमें बड़ा फ़ायदा है। तो लेकिन आप देखें कि कितने ऐसे बच्चे होंगे जो जिसमें इतनी कैपेबिलिटी होगी कि वो बिल्कुल जंप करें, तो मे बी 10%, लेकिन ये 10% भी करते हैं तो अच्छा बात है। तो मुझे लगता है कि इसके अपॉर्चुनिटी है, ये अच्छी चीज़ है कि हम ये फ्लेक्सिबिलिटी दे रहे हैं उनको। दूसरे थोड़ा सा ये एक सोचने के लिए भी है कि हाँ मैं और क्या कर सकता हूँ, स्ट्रेट जैकेट में आप सोचते ही नहीं हैं। स्ट्रेट जैकेट में आपने कह दिया कि हाँ मैंने इलेक्ट्रिकल में बी की है तो मुझे एमई भी इलेक्ट्रिकल में ही करनी है।
हाँ,
तो वो आज कम से कम एक अपॉर्चुनिटी है सोचने के लिए। तो ये सोचते हैं कि, लेकिन ये है कि यदि आप में कैपेबिलिटी नहीं है और आप जंप करके देन यू मे नॉट सक्सीड ऑल्सो। तो ये डिपेंड करेगा इंडिविजुअल में। उसमें मुझे लगता है यदि 5 या 10% भी उस कैपेबिलिटी को यूज़ करने लायक हैं और वो करते हैं तो इट्स गुड थिंग। पर ये सोचना कि एकदम से बहुत बड़ा एकदम से सब कुछ बदलाव आ जाएगा, दैट आई थिंक इज ए बिग थिंग।
नहीं, इससे ऐसे आपको लगता है क्या कि जैसे बीए बीएससी के जो बच्चे हैं ये जो मेजर और माइनर सब्जेक्ट्स लेते हैं, ओपन इलेक्टिव्स वो लेंगे इससे, तो उससे उनके प्लेसमेंट या अपॉर्चुनिटीज़ में कुछ चेंज हो सकता है या बढ़ेंगी या कम होंगी इससे?
मैं जो सोचता हूँ ये कि उसको एक मौका मिलेगा यदि उसका इंटरेस्ट है। यदि आज एक कोई साइंस पढ़ रहा है लेकिन उसको लगता है कि मुझे मैथमेटिक्स में जाना है,
हाँ,
तो उसको अपॉर्चुनिटी है कि वो प्योर मैथमेटिक्स फॉलो कर सकता है।
कर सकते हैं।
तो ये उसको जज करना है कि उसमें वो कैपेबिलिटी है कि नहीं। यदि जस्ट केवल अपॉर्चुनिटी है इसलिए वो जा रहा है तो वो गलत होगा, क्योंकि अब पहले तो अपॉर्चुनिटी नहीं थी,
हाँ,
अब वो अपॉर्चुनिटी है,
वो खुद चूज कर सकता है।
कर सकता है। पर वो उसको चूज करने के लिए खुद को असेस करना पड़ेगा।
हाँ,
दैट्स इम्पोर्टेंट।
सर, हम ऑडियंस को बता सकते हैं क्या सोशल इंजीनियरिंग का मतलब क्या होता है?
देखिए, बेसिकली हम लोग सोसाइटी से जुड़े हैं और किसी भी तरह की इंजीनियरिंग सोसाइटी से तो जुड़ती है, लेकिन कुछ एस्पेक्ट ऐसे होते हैं जो सोसाइटी को बहुत गवर्न करते हैं। अब इसमें इंजीनियरिंग शब्द कई बार हम लूजली यूज़ करते हैं। अब जैसे मायावती जब ऊपर उभरी तो उन्होंने एक ये नारा दे दिया कि हम ब्राह्मणों को और जो शेड्यूल कास्ट वगैरह हैं उनको बढ़ावा दिया। अब उसका ये सॉर्ट ऑफ पॉलिटिकल गेमिंग था वैसे, लेकिन उसको आप ये भी कह सकते हैं कि शी वॉज ट्राइंग टू नैरो डाउन द डिफरेंस बिटवीन अपर कास्ट एंड लोअर कास्ट। यदि हम उस डिफरेंस को ला करके या उसको कम कर रहे हैं तो आई वुड कॉल इट सोशल इंजीनियरिंग। वो रियल इंजीनियरिंग नहीं है, इंजीनियरिंग सेंस में नहीं है, लेकिन एक तरह से वो इंजीनियरिंग है। हम एक सोसाइटी को चेंज कर रहे हैं। एक बात मैं और आपको बताता हूँ, मेरे हिसाब से सोशल इंजीनियरिंग एंड सोशल चेंज के पॉइंट ऑफ व्यू से या सोशल इनोवेशन के पॉइंट ऑफ व्यू से सबसे ज़्यादा डिफरेंस जो दिया है वो गुरु गोविंद सिंह ने दिया है। उन्होंने क्या कहा, देखिए वो हमको उस एरा में जाना पड़ेगा। वो फाइट कर रहे थे औरंगजेब से और औरंगजेब के पास बहुत सशक्त सेना थी, उनके पास इतना नहीं था, उनके पास रिसोर्स नहीं थे। तो उन्होंने कहा कि अपने घर का, मैं गुरु हूँ, जो अपने घर का जो बेटा है, बड़ा बेटा, एल्डेस्ट सन, वो मेरा शिष्य होगा, वो आपके साथ रहेगा, जो आप काम करोगे वो करेगा, लेकिन जिस दिन मैं आवाज़ दूंगा वो आ जाएगा। और उन्होंने ये 5 कक्के बोलते हैं का, कड़ा, कंघा, केश, कच्छा, कृपाण, इसके लिए अलग अलग रीज़न है, मैं उसको अभी डिटेल में नहीं जाऊंगा, लेकिन उन्होंने उसकी एक पहचान बना दी कि वो उनका शिष्य है। तो घर में यदि 3 लड़के हैं तो एक शिष्य है, उसको सिख बोल दिया, और बाकी 2 हैं वो तीनों सब साथ काम कर रहे हैं, लेकिन जब आवाज़ आई गुरु को ज़रूरत है तो वो चला जाएगा लड़ने के लिए। तो उन्होंने एक ऐसी आर्मी बनाई जिसका ना खर्चा था खाली एक रिलीजियस सेंटिमेंट को दे करके एक आर्मी क्रिएट की। इससे बड़ी सोशल इंजीनियरिंग और क्या होगी? और उन्होंने उसको एक एक्चुअली एज पर गोविंद सिंह इट वॉज नेवर मेंट टू बी रिलीजन बाई इटसेल्फ, एंड इट्स नॉट रिलीजन बाई इटसेल्फ। वो एक सोशल इंजीनियरिंग है जो उन्होंने की, और बहुत बड़ी सोशल इंजीनियरिंग है। उसका डिफरेंस ये रहा कि हम इस राष्ट्र को उस टाइम पर किसी हालत तक बचा पाए, पूरे पंजाब को। एक और है मैं कहूँगा एग्जाम्पल स्वामी दयानंद सरस्वती का। वो आर्य समाज की प्रवर्तक थे, आपको मालूम है। उस समय क्या हुआ था, खासकर पंजाब में ऐसे बहुत सारे विलेजेस में ये औरंगजेब के लोग गए और ये मुस्लिम लोग गए और उन्होंने एक दावत दी लोगों को, सबको, और उसमें गाय का मीट मिलाया ना मिलाया, लेकिन खाने के बाद कह दिया इसमें गाय का मीट था, अब तुम सब लोग हिंदू नहीं रहे, मुसलमान हो गए। और ये ऐसा एक दो जगह नहीं हुआ, सैकड़ों हजारों गांव में हुआ। तो दयानंद सरस्वती ने ये कहा कि कोई बात नहीं, तुम गंगा जल पी लो, शुद्ध हो गए, वापिस हिंदू बन गए। तो उन्होंने रिकन्वर्ट किया, उन सब वापिस को हिंदू बनाया। तो एक तो मुसलमानों की इंजीनियरिंग हो गई, उन्होंने फैलाने के लिए खाली अफवाह दिया, सचमुच में दावत दे करके गाय का उनको कन्वर्ट कर दिया। तो सोशल इंजीनियरिंग इज ए बिगर वर्ड इन द सेंस दैट इट ट्रांसफॉर्म्स योर सोशल एस्पेक्ट्स ऑफ लाइफ इन सम बिगर वे। अब इसके आज यदि हम अपने सोसाइटी को ग्लोबल वार्मिंग के अगेंस्ट जागृत करते हैं, कहते हैं कि भाई आप फ्यूल कंजम्पशन मत करो, या सोलर घर में सोलर पैनल लगाओ, या जितना हो सके आप उसके काम करो जिससे आपकी कार्बन डाइऑक्साइड कम हो, ज़्यादा पार्ट ऑफ सोशल इंजीनियरिंग। तो सोशल इंजीनियरिंग एसेंशियली विच रियली ट्रांसफॉर्म द सोसाइटी इन सम डायरेक्शन, गुड और बैड डिपेंड्स ऑन योर इंटेंशन।
मेरी सोच बहुत ही डिफरेंट थी सर।
Pardon?
मेरी सोच सोशल इंजीनियरिंग की बहुत ही डिफरेंट थी। मुझे ऐसा लगता था सोसाइटी के बेनिफिट के लिए कुछ करो तो हो गया सोशल इंजीनियरिंग। फॉर एग्जांपल अभी फार्मर्स के पास बैल नहीं है, तो एक इंजीनियर ने मैकेनिकल बैल बनाया, सो ये हो गया, इट इज द बेनिफिशियल ऑफ द सोसाइटी। सो माय थॉट प्रोसेस वाज दैट
वो सोशल इंजीनियरिंग नहीं है।
बेनिफिशियल फॉर द सोसाइटी इज द सोशल इंजीनियरिंग।
बेनिफिट ऑफ सोसाइटी इज फॉर इंजीनियरिंग। एक्चुअली इंजीनियरिंग आप जो कह रही है वो इंजीनियरिंग है, वो उसमें सोसाइटी बेनिफिट हो रही है, लेकिन जो सोशल इंजीनियरिंग है वो जो वर्ड है वो सोसाइटी को कोई भी ट्रांसफॉर्म करके डायरेक्शन देना। मैंने कहा ना गलत या सही, ये अपने अपना असेसमेंट पे होगा, और ऐसे कई डायरेक्शंस आए हैं। अब जैसे मैं कई बार कहता हूँ कि हम लोग गुलाम हुए, उसके पीछे एक बहुत बड़ा कारण हमारी सोच थी कि हमने वसुधैव कुटुंबकम के साथ में ये भी कह दिया कि यू बी सेटिस्फाइड विद व्हाट यू हैव, आप उसी से सेटिस्फाइड रहो जो आपके साथ पास है। मैं कहता हूँ इससे ज़्यादा खराब सोच इनोवेशन को ख़त्म करने के लिए हो ही नहीं सकती। जब आप उसी से सेटिस्फाइड है, फिर इनोवेट क्या करेंगे? इनोवेशन हम क्या कहते हैं कि कुछ ऐसा करो जिससे कुछ नया बने। तो हम अपनी सोसाइटी, एक्चुअली कई बार लोग कहते हैं कि आज के जो बच्चे हैं उनमें पेशेंस नहीं है, वो हमेशा, मतलब अच्छी बात है, यदि पेशेंस नहीं है तो वो कुछ करेंगे नया। तो हमको ये भी पार्ट ऑफ सोशल इंजीनियरिंग है। तो हमारी कुछ जो सोशल इंजीनियरिंग रही ना, वो कुछ गलत डायरेक्शन, मेरे ख्याल से तो गलत डायरेक्शन नहीं, लेकिन हम कहते हैं वसुधैव कुटुंबकम जो हमारी है वो भी हमारी सोसाइटी का इंजीनियरिंग पार्ट है। हमने अपनी सोसाइटी को इस तरह से ओरिएंट किया है कि वो पूरे विश्व को एक परिवार के रूप में देखती है। इट्स पार्ट ऑफ सोशल इंजीनियरिंग। तो सोशल इंजीनियरिंग को हमको डायरेक्ट इंजीनियरिंग से नहीं जोड़ना है।
Which revolutionize the society positive way.
मैंने बताया ना, पॉजिटिव और नेगेटिव डिपेंड करता है आउटलुक पर। जो X के लिए पॉजिटिव हो, Y के लिए नेगेटिव हो सकता है, उसको हम नहीं करेंगे.
Sir, for any successful man, there is a woman behind. So, is it true for you also?
No, it's true to the extent that I never bothered about home. मुझे पता ही लगा कि मेरी बेटी कब बड़ी हो गई, वो सारी शोभा की जिम्मेवारी थी. तो मैं ऑफिस जाता था, जब मैं इसरो में था, तो नॉर्मली आई यूज्ड टू लीव बाय 7:30 एंड आई यूज्ड टू बी बैक ओनली बाय 8:30 नाइट. तो कब बच्ची बड़ी हो गई, कभी हो गया, कब हो गया, तो बहुत बड़ी बेकिंग होती है. जैसे अभी मेरे से पहले चंडी जी ने कहा था ना कि फैमिली सपोर्ट, यदि हम हमारे ऊपर वो बर्डन हो जाए कि हाँ यहाँ क्या होगा. अब मैं घर बना रहा था, उसमें एप्पल प्रोजेक्ट चल रहा था और मैं अपने इसरो के पास में रहता था, तो वहाँ से करीब करीब 20 किलोमीटर है. तो शोभा रोज़ सवेरे सुपरवाइज करने के लिए बस से जाती थी और शाम को बस से आती थी, तो तब मेरा घर बना. तो यदि सपोर्ट नहीं होता, यदि मुझे जाना होता तो मैं कहाँ ही सफ़र करता. तो उसमें बहुत बड़ा हाथ है.
Great. So, kudos for ma'am. She is there. Claps for ma'am.
Solar power. I don't remember the exact numbers now. But when you look at the growth of solar power in last 5 years, the Modi ji had made a promise of 100 gigawatt installation by 23. I think we have exceeded that. So we are not lacking. There are other issues related to solar power. See, solar power is available, in fact 100 gigawatt for solar and 150 or 70 for total renewable including the wind. So we are more or less reaching that target. So we are not lagging. But the issue with solar power further increases the stability of the grid, because solar power is available only at daytime. Daytime consumption is largely by the industry. But there are many industries, they really run around the clock also. The peak power is in the evening. So how to stabilize a grid? So that is going to be a big problem now. So when we grow with solar power, see, we are talking of about I think 2030, our goal is 30% of renewable energy. See, I'm not talking of connected power or the installation capacity, because solar power, when you have a, let's say, 1 megawatt installation, the power you don't get 1 megawatt all the time. Power you get only for the 8 hours, no? So your average power is almost 1/4 of that. And that too, getting fluctuation by clouds and mostly by clouds. So those problems are there with solar power. Similarly, wind also is not continuously available. So these so-called renewable powers require stabilization. Now, stabilization comes either from coal. The old coal plants, they had a very low ramping rate. They were not able to stabilize. But new plants which are coming, super thermal power, they are able to stabilize faster. But actually, what you will need is lot more ramping fast, which can come either from battery or from so-called pump hydro. Our capacity in the country in pump hydro is very small. So there are some efforts going on. The battery is very expensive. Now, when you really look at the battery and solar power, the solar power, as I was mentioning earlier, from 1960 to almost 2000, 40 years or maybe 2010, it was practically constant. Now it is sharply dropping down. It already dropped down to almost, actually I was getting a number some time back, we are almost 2 cents per kilowatt, per watt in terms of cost. No, 20 cents. And they are expecting that 2 years will go to even 10 cents. So it's coming down continuously. So solar power installation will grow, in that there is no doubt to me. But whether we will be able to stabilize the grid with that, that requires a lot more battery or a lot more nuclear power. Because nuclear plants are able to ramp up relatively faster compared to the coal. So the future problem, see why we are talking of becoming zero emission only by 2070. That is mainly because, firstly, we have to replace also in transportation, in vehicles. So we have to go to EV. There are a lot more policy changes needed. For example, when we increase solar power more, we have to have a time-dependent charging of the energy. But on one side, we are giving free energy. So how do you charge only daytime when there is a free energy? So there are a lot of political things which are messing up this complete, I would say, technology planning. Technically, I should be giving, let's say, half the price of energy at daytime and double the price in the evening time. Because that time, I have to really draw from the coal and elsewhere. But that thing is becoming difficult with this so-called political situation. But the short answer to your question is that India is not doing bad. India is doing reasonably much better than many other countries in terms of solar power. In future, next 10 years, it will depend whether we are able to simultaneously also add things like battery, hydro. There is a new concept coming now, gravity pump. It's only experimental stage. No one has really perfected the technology in the world. If the gravity pump technology gets stabilized maybe next 10 years or so, that may solve this problem of fluctuation. What it will do is it will just lift a very heavy weight of maybe 1,000 ton or megaton when the power is available, and lower down and generate energy when it is needed in the night time. So like that, there are many technologies, but you need a stabilizing technology, grid stabilizing. So that is a major challenge. Now coming to, let's say, ISRO. So far, the focus was for space for national development, space for society. But we also, as I said, mentioned about Chandrayaan-1 discussion, we also cannot oversee the national aspirations. When we grow in terms of economy, then aspirations also grow, and we have to keep the national aspirations also along with that. So, what is national aspirations? National aspiration tells us that, okay, we should also aspire to become leaders in technology, leaders in exploration. And that's where the programs like Chandrayaan-3, we have succeeded. Now, I have not gone into the details of that. I'll come maybe 1 minute later. But then what is the next challenge? Next challenge is to put man into orbit. Third challenge will be to put man on the moon. Fourth challenge will be, okay, put man on the Mars. Now, on one side, there are challenges. The other side, the people will ask question, okay, what do you do with that? Just because man goes in space, what do I gain out of it? So there are a lot of people who will say, okay, if you say money goes to schools, making buildings, making roads, that is much more useful. You make more schools, more roads, better roads. Why are you doing that? So this dilemma always goes. So then you have to find a balance. That on one side, you also do the things which aspires. See, when we talk about Chandrayaan, the whole condition got aspire. Inspiration came. That is also important. But then it doesn't serve an earthly purpose, it doesn't give food to our people. So these programs have been envisaged, already been considered. We will have mission. In fact, Mr. Somnath, Chairman of ISRO, has announced recently, he has given the timetable also. He talks of that man in the orbit by 2030, He talks of man on moon by 2040. He's already announced that. We are talking of a development of a super heavy launch vehicle also. We are developing now the semi-cryogenic technology for the booster engine. This will be LOX methane. So all those developments are going on. So again, someone will say, okay, you are not leading in these areas, you are following. I would say, what is wrong with following? Because these leading areas, we are keeping aspirations on, but we don't have to really lead in this area going ahead of USA. We don't have to do that. Let US lead, let's follow. So, but still keeping the aspirations on. So this is with respect to the mission to ISRO's mission. So we have to develop this technology. See, just to think of Chandrayaan 3. You have all seen pictures, right? You have seen how the moon is. Now, when we are orbiting at 100 kilometers, the velocity of the orbiter was 1.6 kilometers per second. Now, when you are landing, it was horizontal velocity. When you are landing, so your horizontal velocity will be 0, and your landing velocity also has to be less than 3 meters per second. Otherwise, you will hit the ground with the force, and you will break. So that's one part. So that means you have to really break this velocity. Now, how do we measure the velocity? When I'm coming from 1.6 kilometer per second to 0 velocity, how do I measure? So there are sensors, we call it inertial sensors. We have accelerometer and we integrate the accelerometer. So if you are making such a kind of a calculation, that means you are reducing, let's say, up to 1 meter, because if my velocity when I'm moving, landing, if my horizontal velocity there, then it will topple. So my horizontal velocity has to be less than 1 meter. So that means my accuracy of measurement, I'm coming from 1,600. So 6,000 to 1 meter, this much ratio, my instrument has to give without any physical measurement. So these are the challenges. Similarly, when I'm landing, I have to see that I should not get into a slope more than like 10 degrees, otherwise it will topple. I have to see that there is no boulder there. If I put on boulder, again I will topple. So there are all these technologies that go simultaneously to look at it. And that's why the instrumentation part, the algorithm that go into guiding this, the algorithm will go into looking at the picture earlier which we have seen, put into this and then matching, because you want to land at this place which is safe. So there are very complex technologies and all that have been done. So similarly, when you talk of putting man into the orbit, what is involved? One is you have to provide a life support system. You are putting man not to leave him there, you have to bring it back safely. So the challenge is not putting man, challenge is bringing back safely. That's important. Okay. Similarly, when you are really talking of putting in man also, you have to have one order better of reliability. For example, when we launch a satellite normally, we have, let's say, avionics system which has got redundancy, one chain, two chain. If one fails, other one takes over. If I have to put man, I'm not satisfied even with 3, I have to put 4 chains. If one fails, second, if second fails, that also I should go. In fact, second fail, we don't say go. Second fail means should come back. So only one fail safe, second fail is bring back. So we have to have 4 chains. Similarly, your reliability, your safety margins have to be much higher. If I was having 1 mm thickness of the rocket shell, I have to make it 1.2 mm now. So all these changes are required when you put a man into the orbit. So you have to have an additional level of reliability. Then if something goes wrong, still, suppose there is a bust. If satellite is there, okay, let it go bust. But man you cannot allow. So I have to have a system that ejects it and lands it separately. So all these additional features, there are technical challenges. So you really work for technology. You work for capability. You work for ambition. You work for inspiration. You really don't work what you will get out of it. So these are the differences. So someone will always question, why are you doing this? So this is where government or decision makers have to balance that. But we have already got these missions very clear definition up to 2040. Okay? Now third question was Dr. Kalam. See, Dr. Kalam, he started working on project SLV. SLV3, which we call, he was the first project director of SLV3. Then, after some time, Professor Dhawan brought him to headquarters, and then he shifted to the so-called DRDL of lab of Hyderabad in Hyderabad, of DRDO. Now, he did a very pioneer thing. He developed the capability of so-called reinforced plastic in those days. In 72, he developed a laboratory separately using not carbon fiber, that time it was glass fiber for rocket motors. So he introduced the technology. But he became famous as a missile man because actually when you look at in space, he was the first project director of SLV3, but later he had moved out of ISRO. He is much more known as a missile man because he created an integrated missile program in DRDO or in the country. And he was the person who is responsible for launch of Prithvi 1, Prithvi 2. He started with that. So his contribution to ISRO is certainly is there, but he moved much earlier when this more complicated. In fact, I think he was moved after the first flight of the SLV3. Then later, his career is more in the defense side, and that too in the development of the missiles. Professor Dr. Kalam is one of the best man manager. He knows how to take work from hundreds of people. Thousands of people. If you are working in any of these areas in which Kalam is involved, you can get a call right 11 o'clock, hey Goel, what are you doing? Like that he'll ask questions. So he is a very hardworking person, committed person, but one of the best man manager. He is not a best technology person because technology is done by others. He managed to get technology developed. That was his capability. Okay?
Thank you, sir. Here comes the end of the conversation and interaction with Dr. P.S. Goel, former Director, ISRO, Bengaluru. Now I would like to request Mr. Prajwal Mitawala, our volunteer, Gyanyajnah Foundation, to please felicitate Dr. P.S. Goel on behalf of NGO.